Today we are going to see Geography, Unit 2, Climate and Natural Vegetation of India. Unit 2, Climate and Natural Vegetation of India. Learning Objectives. Learning Objectives. To describe the factors controlling the climate of India. To describe the factors controlling the climate of India. To understand the characteristics of different seasons in India. To understand the characteristic of different seasons in India. To know about the rainfall distribution. To know about the rainfall distribution. To study the different types of natural vegetation and wildlife in India. To study the different types of natural vegetations and wildlife in India. Introduction. We drink more water during summer. Normally, in summer season, during the month of April, May, March, April, May, we will drink more water, plenty of water we will drink during the summer month. And we will not drink, we do not drink the same amount of water during the winter. For example, November month, December month. Will we drink more water? No. On the winter month, we will take the little water. So, we drink plenty of water during the summer month and do not drink the same amount of water during the winter month. Why do we wear cotton or lighter clothes during summer? It will be very hot. We will get sweat. Instead of that, we will wear the summer season. We will wear the lighter wear cotton due to the hot. And we will wear the heavy woolen clothes during the cold weather to protect us from the cold. So we will wear the woolen clothes during the cold weather season in North India. Why do not we wear woolen clothes in South India on the summer season? This is because of the prevalence of varying weather condition between North and South India. In the previous chapter, you have learnt about the landforms and drainage of our country, which deal with the natural environment. In this chapter, you will learn about the climate, rainfall, distribution, natural vegetation and wildlife of our country. What is meant by equable climate? Equable climate is also called as British climate, which is neither too hot nor too cold. Equable climate is also called as the British climate, which is neither too hot nor too cold. What is meant by weather? Weather refers to the state of atmosphere of a place at a given point of time. It is known as weather. Weather refers to the state of atmosphere of a place at a given point of time. Climate. What is meant by climate? Climate is the accumulation of daily and seasonal weather events of a given location over a period of 30 to 35 years. Climate is the accumulation of daily and seasonal weather events of a given location over a period of 30 to 35 years. Meteorology. The branch of science concerned with the processes and phenomena of the atmosphere, especially has a means of forecasting the weather. Meteorology, the branch of science concerned with the processes and phenomena of atmosphere, especially has a means of forecasting the weather. Season. Each of the 4 divisions of the year, spring, summer, autumn and winter, marked by particular weather patterns and daylight hour. Season. Each of the 4 divisions of the year, spring, summer, autumn and winter, marked by particular weather patterns and daylight hour.
In this video, we're going to quickly understand what are the factors affecting India's climate. Now, generally speaking, I'm not just talking about India. There are 6 major components that controls the climate of any place. They are latitude, altitude, pressure and wind system, distance from the sea, ocean currents and relief features. Let's understand each one of them. The first one is latitude. Due to the curvature of the Earth, the amount of solar energy received varies depending on the latitude. That's why you'll see the temperature decreases as we go away from the equator towards the poles. This is the equatorial region, from Tropic of Cancer in the northern hemisphere to Tropic of Capricorn in the southern hemisphere. There's another name to it called as tropical zone or torrid zone. As we go further away, we have the temperate zone or the temperate region. This is the area lying in between Tropic of Cancer and Arctic Circle in the northern hemisphere, and in the southern hemisphere it is between Tropic of Capricorn and Antarctic Circle. Now this area has a pleasant climate. That's why you will find most of the tourist destinations in the world located at temperate regions. As we go even further away, we have the frigid zone. It's cold freezing out here. This area is in between the Arctic Circle and the North Pole in the northern hemisphere, and in the southern hemisphere it is between Antarctic Circle and South Pole. So these were all the latitudinal changes that affects the climate of a place. The second factor is altitude. Altitude means height. The more you go above the ground, that is from the surface of the earth to higher altitudes, the temperature decreases. Because the concentration of air molecules decreases, we also call it as thin air. That's why when you go to hill stations, it's cool out there. The third factor is pressure and wind system. By pressure we mean high and low pressure system. Always remember, air moves from high pressure to low pressure area. The best way to understand this, I have given this illustration before, so I'm going to use it again. Switch on the AC in your room and leave the door open. You will feel the cool air going out of the room, and this is because the environment outside your room is warm and it's attracting the cool air molecules towards it. Hence, by this example, you can also understand this. Landmass gets heated faster than water bodies, and due to that, a low pressure zone is created at the land surface, which attracts cool air molecules from the sea or ocean, causing rainfall and changes in the temperature. The fourth factor is distance from the sea. Now, if you're residing at coastal areas, you will notice there is hardly any change in the weather condition. I mean, you will be constantly facing the wind from the sea, so there isn't going to be much differences in the weather condition. But as you move away from the coastal areas towards central part of the landmass, you will start to witness extreme weather changes like very hot during summer and very cold during winters. This condition is known as continentality. The fifth factor is ocean currents. It is a continuous movement of ocean water from one place to another. Ocean currents are created by wind, water temperature, salt content, and the gravitational pull of sun and the moon. Generally, there is 2 types of ocean currents, cold and warm currents. You can see them in this picture. The red arrow indicates warm currents and the blue one are cold currents. If you notice, most of the warm currents are near the equatorial region. That's where the sun rays falls directly and are found in abundance. So the theory is these warm and cold current influences the local winds of the nearby landmass and causes change in the climatic condition. For example, with warm currents, the landmass face warm and humid climate. And the last factor is relief features. In geography, the meaning of relief is typical high and low lying areas like mountains, plateau, plain, deserts, etc. High mountains act as barriers for cold or hot winds, just like we have the Himalayas that protect us from the cold chilly wind of the Arctic. And it is also due to these mountains, precipitation takes place. One such example would be the mountains of Western Ghats that lie in the path of the rain-bearing southwest monsoon winds. So these were the 6 factors that affects the climate of India, not just India, any place of
India. Many people get confused between the weather and climate. So at first, let's look the basic difference between the weather and climate. Climate refers to the sum total of weather conditions and variations over a large period of time. It should be more than 30 years. Whereas weather refers to the state of the atmosphere over an area at any point of time. The elements of weather and climate are almost same. These are temperature, atmospheric pressure, wind, humidity, and precipitation. You may have already observed that the weather conditions fluctuate very often even within a day. But there is some common pattern over a few weeks or months. Like sometimes we tell days are cool or hot, windy or calm, cloudy or bright, or it can be wet or dry. So, on the basis of mean monthly atmospheric conditions, the year is divided into seasons, such as winter, summer, or rainy seasons. Do you know what type of climate India has and why it is so? We are going to learn everything in this chapter. Let's move. The climate of India is described as monsoon type. In Asia, this type of climate is generally found in the south and in the southeast. Despite an overall unity in general pattern, there are regional variations in climatic conditions within the country. Let's take two important elements. These are temperature and precipitation. Let's explore how they vary from place to place and season to season. In summer, the mercury occasionally touches 50 degrees centigrade in some parts of the Rajasthan desert, whereas it may be around 20 degrees centigrade in Pahalgam in Jammu and Kashmir. On a winter night, temperature at Dras in Jammu and Kashmir may be as low as minus 45 degrees centigrade. But on the other hand, Thiruvananthapuram may have a temperature of 22 degrees centigrade. Now, let's look the next element, which is precipitation. There are variations not only in the form and types of precipitation, but also in its amount and the seasonal distribution. While precipitation is mostly in the form of snowfall in the upper parts of Himalayas, it rains over the rest of the country. The annual precipitation varies over 400 cm in Meghalaya to less than 10 cm in Ladakh and western Rajasthan. Most parts of the country receive rainfall from June to September. Some parts like Tamil Nadu coast gets a larger proportion of its rain during October and November. In general, coastal areas experience less contrast in temperature conditions, but seasonal contrasts are more in the interior of the country. There is a decrease in rainfall generally from east to west in the northern plains. These variations have given rise to variety on lifestyle of people in terms of food they eat, the clothes they wear, and also the kind of houses they live in. Now, we are going to discuss the 6 major factors that control the climate of any place. They are latitude, altitude, pressure and wind system, distance from the sea, ocean currents, and relief features. For India, 4 factors together play major role. These are latitude, altitude, relief, that means the presence of northern mountains, and distance from the sea. First, we are going to discuss the latitude. Due to the curvature of the earth, the amount of solar energy received varies according to latitude. Let's explore latitude with Google Earth. As you know, India is a tropical country. The mainland stretches from 8 degrees 4 minutes north to 37 degrees 6 minutes north.
Now, we are also aware of the fact as we go away from the equator towards pole, temperature as well as rainfall decreases. The reason for this phenomenon is the incoming solar radiation. At the equator, the sun rays are the most direct on the earth. But as you move towards pole, the sun's angle on the sky decreases, and as a result, incoming solar intensity also reduces. The total length of India from north to south, it is about 3214 kilometers. This huge latitudinal variation keeps tremendous effect on the climate from warm Kanyakumari to cold Kashmir.
So at the end we can say the Tropic of Cancer passes through the middle of the country from the Rann of Kutch in the west to Mizoram in the east. Almost half of the country lying south of the Tropic of Cancer, that means belongs to the tropical area, and remaining portion, that is north of the tropic, lies in the subtropics.
Now, what is subtropical region? The subtropics are geographic and climatic zones located roughly between the tropical zone and temperate zone.
Though India's climate has characteristics of tropical as well as subtropical climate, but India is generally said to have the tropical monsoonal climate, which means that temperature here are higher than those in the temperate latitudes. So here you already know that India is a tropical country. Especially the southern part of India lies near the equator and is therefore warm all year around. Now let's move to the various hill stations of southern India like Oti and Kodaikanal. But if you go during summer, you will feel cold. But why is it so? It is closer to the equator, so it should be very warm during summer or throughout the year. Yes. Here you have to remember one thing. Whenever we tell about the parameters which control the climate of a place, we always use the word parameters or factors. That means only one factor or one parameter never control the climate of a place. Together, all parameters control the climate of a place, or sometimes one parameter can act as an active factor where the other parameters act as passive factor. So here please remember, latitude is acting as a passive factor. Please remember, as one goes from the surface of the earth to higher altitudes, the atmosphere becomes
less dense
and temperature decreases. That's why the hill stations are cooler even during summer. Now, you already know that India has mountains to the north, which have an average height of 6,000 meters. India also has a vast coastal area where the maximum elevation is about 30 meters. The Himalayas prevent the cold winds from the Central Asia from entering the subcontinent. It is because of these mountains that this subcontinent experience comparatively milder winter as compared to the Central Asia. And this big relief also play a major role in determining the precipitation of a place. Like if they are high enough and lie in the path of rain-bearing winds, the windward side of the mountain will get enough or high amount of rainfall, whereas the leeward side of the mountains remains relatively dry. Because of this, the windward side of the Western Ghats receive high amount of rainfall, whereas the Deccan Plateau remains dry because It is situated in the leeward side of the Western Ghats. Here observe another important thing. Because of the presence of Aravalli mountain, Western Rajasthan receives no rain from the Arabian Sea branch. As a result, it turned into desert region. Yes, I am talking about Thar Desert. Here if you observe carefully, you can see Aravallis are parallel to the Arabian Sea branch of southwest monsoons. That's why the rain-bearing winds are unable to cross the barrier and it blows parallelly. So we can say the Western Rajasthan lies in the rain shadow region or the leeward side of Aravalli mountain. And this is the reason Thar has turned into desert. The next factor is the distance from the sea. The sea exerts a moderating influence on climate. As the distance from the sea increases, its moderating influence also decreases and the people experience extreme weather conditions. This condition is known as continental climate. That means very hot during summer and very cold during winter. But places nearer the coast such as Mumbai and Chennai have moderate summers and winters. That means summers are not too hot and winters are not too cold. That's all about the factors affecting climate of India. I hope this video is informative for you. So, stay happy, stay safe. I'm going to meet you very soon. Bye.
Jet streams are another name for fast-flowing currents of air. There are many different jet streams that exist at both high and low levels in the atmosphere. Each has an important role to play in the weather experienced on Earth. The major jet streams that circle the Earth are found just below the tropopause at a height ranging from 9 to 16 kilometers and can reach speeds over 200 miles per hour. They are hundreds of kilometers wide but only a few kilometers deep, so are often described as a ribbon of very strong winds. The major jet streams are the polar front and subtropical jets. These occur in both the northern and southern hemispheres and are part of the larger global circulation. The polar front jet occurs over mid-latitudes and strongly influences the weather over the UK and Europe. The polar front jet is a type of thermal wind that arises due to the strong temperature contrast between cold polar air and warm tropical air. To explain this further, imagine two columns of air, one in the cold air to the north of the jet and one in the warm air to the south. The top of each column is bounded by the tropopause. A shorter column of cold air exerts the same surface pressure as a taller column of warm air. This is because in the cold air column the air is more dense. This causes atmospheric pressure to decrease more quickly with height. In the warm air column, pressure does not decrease as rapidly with height because the warmer air is less dense. The tropopause in both columns is at the same atmospheric pressure. So if you were to climb to the same height in both columns, you would find that you would be at a lower atmospheric pressure in the cold air column and a higher atmospheric pressure in the warm air column. The pressure difference caused by this temperature gradient produces a pressure gradient force. The pressure gradient force acts from high to low pressure, so theoretically in the northern hemisphere, air would flow from south to north. But the Coriolis force resulting from the Earth's rotation causes the air to move to the right of the direction of motion in the northern hemisphere and to the left of the direction of motion in the southern hemisphere. In both hemispheres, the jet stream flows parallel to this temperature gradient, moving from west to east. Theoretically, this jet encircles the Earth in a continuous line, but in reality, it is more broken up. as differential heating of land-sea masses lead to west to east temperature contrasts as well as north to south. As the polar front jet forms due to the temperature contrast, the stronger the temperature gradient, the stronger the jet. This means that the jet is stronger in the winter than the summer as the poles cool during the winter months, increasing the temperature contrast. In the northern hemisphere, the jet tends to be further south in winter and further north in summer. This is due to the tilt of the Earth, and that in the winter, the northern hemisphere is tilted away from the sun, and in the summer, it is tilted towards the sun. Mid-latitude low-pressure systems occur on the polar or northern side of the jet stream, while more settled, warmer conditions are found to the south. This gives us the wet and windy weather we often see in the UK during the winter months, as low-pressure systems are steered towards us. It can also lead to some disappointingly wet summers if the jet stream remains to the south of the UK. A stationary jet stream pattern will bring frequent low-pressure systems to the same region. When warm air moves further north than normal, or cold polar air moves further south, this can change the prevailing west to east jet stream pattern. This causes the jet stream to buckle, driving depressions towards different regions or blocking their movements altogether. A straight west-east flowing jet stream won't have much impact on the development of new weather systems or strengthen pre-existing ones. When a jet stream meanders north and south, air accelerates and decelerates around the bends in the flow. These areas of changing speeds are our development areas. Where the air is accelerating, more air is leaving than entering a certain point. This means that the air is being depleted at this point. To fill this depletion, air from below rises. When air rises, it forms clouds and precipitation. Winds at the surface converge to this rising air column, which causes surface pressure to fall, and a low-pressure system may develop or deepen further. So whilst the jet stream is just an area of fast-flowing air, it has a fundamental effect on our weather.
Few years, the El Niño phenomenon kicks into life in the Pacific Ocean around the equator. It can affect weather around the world, changing the odds of floods, drought, heat waves and cold seasons for different regions, even raising global temperatures. But what is El Niño and how does it happen? Firstly, we need to know what's normally happening in the tropical Pacific. This vast stretch of ocean sees consistent winds, called trade winds, that blow from east to west. These winds push warm water near the surface in their direction of travel, so the warm water piles up on the western side of the ocean around Asia and Australasia. On the other side of the ocean, around South and Central America, as the warmer water gets pushed away from the coast, it's replaced by cold water which is pulled up from deeper down in the ocean, a process called upwelling. This creates a temperature difference across the tropical Pacific, with warmer water piled up in the west and cooler water in the east. Warmer water adds extra heat to the air, which causes the air to rise with more vigour, and it's this rising air that creates an area of more unsettled weather, with more cloud and rainfall. That rising air in the west sets up atmospheric circulation across this part of the world, with warm, moist air rising on one side of the ocean and cooler, drier air descending on the other. This circulation reinforces the easterly winds, so this part of the world sits in a self-perpetuating state until El Niño begins. If conditions are right, tropical Pacific weather systems, or slow changes in the ocean around the equator, can set off a chain of events which weaken or even reverse the usual trade winds. With weakened trade winds, there's less push of warm surface water to the western side of the ocean and less upwelling of cold water on the eastern side. This allows the usually colder parts of the ocean to warm, cancelling out the normal temperature difference. Because the area of warmest water moves, so does the associated wet and unsettled weather. This changes rainfall patterns over the equatorial Pacific, as well as the large-scale wind patterns. It's this change in winds which has a knock-on effect, changing temperature and rainfall in locations around the world. The main impacts are around the tropics, where you see an increase in the risk of floods in Peru and droughts in Indonesia, India and parts of Brazil. But virtually wherever you are in the world, El Niño has the potential to affect you directly via the weather or indirectly via socio-economic impacts. There's another impact from El Niño which happens because of all the extra heat at the surface of the tropical Pacific. This releases vast amounts of energy into the atmosphere, which can temporarily push up global temperatures. This is why El Niño years often feature among the warmest on record. Each El Niño event is different, so the global impacts can change. You can find out more about the differing impacts of El Niño on our website. El Niño peaks around Christmas time and lasts for several months. It can die back to neutral conditions, but sometimes reverses into La Niña. This is the flip side of the oscillation, which sees a strengthening of the normal trade winds. This pushes the warmest water to the far western part of the tropical Pacific and increases the upwelling of cold water in the east. This cooler water extends out from the coast of the Americas towards the central part of the ocean. La Niña also impacts global weather and tends to have opposite effects to El Niño. You can also see more about La Niña and